So at this point, I'd like to hand over to Andrew Teixeira for the first of the faculty perspectives.
Great, thanks Wally for inviting me to talk here. What I'm going to talk to you today about is some of our innovation in our chemical engineering curriculum for our unit operation course, and specifically making it virtual for the hybrid teaching. All right, next slide. So before I get into it, this is an enormous team effort to make all of this possible, from the faculty, our outstanding technicians in chemical engineering, grad students, and a big push from IT to kind of make these visions that I've had and some of these ideas really come to be. So true team effort, and I'll be presenting on behalf of the team. Next slide. So first, let me tell you what the unit operations course is. So this is the senior lab experience for our undergraduates in chemical engineering. It's a 3-story pilot scale facility located in Goddard Hall that has equipment like distillation columns, separations, heat exchangers. That is really that industrial equipment that we want the students to have that hands-on experience of what does it mean to turn a steam valve, to apply heat to a climbing film evaporator, etc. So that's a really tactile experience. And we want to maintain that under these hybrid and tech flex plan operations. So what we decided to do is go at 50% capacity. That means for every group that's typically around 4 students, 2 students are in lab, 2 students are remote. And then we infused a lot of technology with augmented reality, high definition, cameras, and Microsoft Teams meetings that allows the remote students to really engage with the lab students in real time. And the key outcome here was we wanted the remote students to stay involved in actually sampling, recording, and being engaged in the lab. Next slide. So what does this look like? If you're in lab, here are a couple of screenshots. The image on the left has a computer monitor, and that computer is running National Instruments LabVIEW software that's automating and controlling a piece of equipment in the background. That screen is also real-time being cast through a Microsoft Teams meeting to remote users that can see everything that's happening that the local users are doing, and has the two-way communication through the meeting, very similar to a Zoom meeting. On the right image, you see 2 more pieces of technology that I'll be talking about: the HD pan-tilt zoom cameras and the Microsoft HoloLens 2 augmented reality glasses mounted under the student's hard hat there. Next slide. So the first bit of technology are the pan-tilt zoom cameras. So these are not just web cameras. These have a 10x optical zoom that allows them, the remote user, to log in, scan around the lab, left, right, up, down, and zoom in with such high definition that they can read a gauge across the room and actually record the data. So that means the students aren't just at home trusting the lab users to run an experiment. They're actually participating in the experiment, even though they're remote. And we've outfit the lab with 3 cameras per floor. I already told you there are 3 floors in the building, so that's 9 cameras total across that lab. All right, next slide, please. All right, so I've got 2 videos, so go ahead and play the first one. So this is what you're seeing here is a screencast of a Microsoft Teams presentation. So on the bottom, you can see there are some local users, some remote users, and myself, the faculty member that's joined in remotely. The users in real time are typing in and recording data, whether they're local or remote. Other users are performing calculations. And the really cool part is they can then send this to the local user. So now you're seeing a view from the HoloLens where they're superimposing that Excel spreadsheet while students are actually engaging in lab, and everything has this 2-way audio as well, so they're able to participate there. Now go ahead and hit the next video. The last piece of technology is using the Microsoft guides. So some of the experiments have this step-by-step guide that walks them through some of the complex equipment and startup and operation of these columns. So here the student is following a procedure that explains how to turn on or identify the steam on a column. And it's a little jumpy in the stream here, but it's very smooth in person. And you can see these holograms are actually superimposed on different parts of the equipment, which allows them to directly engage with the stepwise procedure. The other cool thing is with de-densifying the labs, the faculty can't always be there telling the students exactly what to do at every step. So we've embedded some videos of technicians, of our lab technician, explaining how to operate each individual piece of equipment here. So you can see here, there's cooling water for a condenser, and the student is being directed. This is how you physically rotate a knob and set the cooling water flow rate. And there's audio associated with this video, and they can actually grab that whole card and drag it over and bring it with them and put it so that way they can directly perform that part of the experiment and then move on to the next step. Okay, next slide. Okay, and just to say this isn't ending here. Rob Dembski, who's gonna be speaking next, and I are working on this grant together to do this similar thing for pharmaceutical engineering and workforce development, and this will be coming next summer. All right, and last slide. And just to bring it all full circle, this is a photo of me teaching Professor DiBiasio the new technology of augmented reality, and it's full circle because Professor DiBiasio there with his technology is the one who actually originally taught me unit operation in my undergraduate curriculum. So